Hello. In this video I provide a demonstration of how to carry out and interpret a multinomial logistic regression, which is generally used when values on the dependent variable represent unordered categories. A link for the data as well as this PowerPoint will be made available for download under the video description. Additionally, a running document containing links to other videos on logistic regression and using other programs will be made available as well. So if you find the video and materials useful, please take time to like the video and share the link with others. And also please consider subscribing to my YouTube channel. So for our example, we are studying predictors of people's voting behavior during the 2016 presidential election. We hypothesize that age, gender identification, economic beliefs, religious beliefs will predict whether a person voted for Hillary Clinton, Donald Trump, an other candidate, or did not vote. And just so you know, the other category on the dependent variable was created because of low frequencies associated with the other candidates. So it's not a terribly informative category, but we're just basically using this as another group. So our sample is comprised of 120 observations. Age is measured as self-reported age of the participant. The economic liberalism variable is basically has individuals rating their beliefs on a scale from 1 being extremely conservative to 7 being extremely liberal. We have a measure of religious liberalism where participants rated their beliefs on a scale from 1 being extremely conservative to 7 being extremely liberal. We also have gender identification, which is coded 0 for identified male and 1 for identified female. So when setting up our analysis, individuals indicating they voted for Hillary Clinton, which is basically those in group 1 on the vote variable, those individuals are treated as a reference or a baseline category against which all of the other groups are being compared. Just so you know, we could also be using a different reference category if we had an interest in other comparisons between a different baseline category and the remaining groups. So briefly, just a few screenshots, and then I'll walk you through the actual steps in SPSS. You'll see that we just simply carry out our analysis by going to Analyze, Regression, Multinomial Logistic. When this box opens up, we move our dependent variable to this box right here, and we move our predictors or independent variables to the covariates box. Gender ID is already a binary variable and it's already dummy coded, so it's permissible to include it as a covariate in the analysis. But if we happen to have a variable that is a factor variable, then we would be putting it right here in the factor box. Also, we would want to make sure that our reference category is correctly specified. So right now, by default, the last group on that 2016 variable is specified. So that would be the did not vote group, and so we don't want that to be our baseline or reference category. So what we need to do is to click on this button right here, and when we do it, we get a little box that opens up right here, and so I'm changing this to first category, which Hillary Clinton was basically coded 1 on that particular variable. You also have the option for a custom reference category as well. So at any rate, once we've made this change, you can see that now it shows up in our box as first. Now when we click on statistics, a number of defaults show up, and I've added this one right here, classification table, goodness of fit. I even added this one right here, but so that's basically the layout for what I've done for this particular demonstration. So let's walk through it using SPSS kind of in real time. So here's our data set, and we'll go to Analyze, Regression, and we'll go down to Multinomial Logistic, and I'm going to reset this and redo it. So we're going to move vote over to the dependent variable box. We're going to move our independent variables over to the covariates box. Under reference category, I'm going to set this as first because that is the value associated with 1 in this particular case, which is going to be the first category, that is Hillary Clinton. So I'm going to click on Continue. Under Statistics, I'm going to go ahead and click on Classification Table and Goodness of Fit, and I can also ask for information criterion if I want. We'll click on Continue and then on OK, and so now we get our output. So first off, you get your general information about the model. You can see that we have basically these are used to evaluate the overall fit of the model, and then we can scroll down and look in the parameter estimates table in order to evaluate the contributions of each of the predictors in the model to discriminating between our baseline category and the comparison group. Finally, down at the bottom, you'll see that we get a classification table. So rather than me walking through the output, I'm going to go back to my PowerPoint to give you a little bit more of a cleaner walkthrough of the presentation. So let's start off with the model fitting information table. So this contains a likelihood ratio chi-square test which compares the full model with all of the predictors against a null or intercept only model. So statistical significance indicates that the full model represents a significant improvement in fit over the null model. So this is the p-value right here. We see that this is indicating statistical significance. So in this case, we would interpret our model containing the full set of predictors as representing a significant improvement in fit over the null. Next, we have the goodness of fit table, which contains deviance and Pearson chi-square tests, and basically in this case non-significance is an indicator of good model fit. So you'll see right here that with the Pearson test, this is actually significant at the 0.05 level. That would actually indicate poor fit, whereas the deviance chi-square test is non-significant. That would actually indicate good fit. And so sometimes it can be the case where the two test results disagree with each other, and that happens to be the case in this particular demonstration. Next, we have the pseudo-R-square values. We've got Cox and Snell, Nagelkerke, and McFadden's. In general, there's not any real strong guidance in literature on how these should be used or interpreted, so I would interpret these with caution. Next, we have likelihood ratio tests, which test the overall contribution of each independent variable to the model. Note too that if a variable is added in as a factor, the result for that variable is treated as an omnibus test of that factor. So using the conventional alpha at 0.05 threshold, we can see that the economic liberalism variable is statistically significant. Age is, I guess you could say it's quote-unquote near significant, as the p-value is 0.051. Okay, so these results provide information comparing each voter group against the reference category. That's the Hillary Clinton voters. Specifically, the regression coefficients indicate which predictors significantly discriminate between persons who voted for Donald Trump, which in this case would be coded 1 in this particular comparison, against those voting for Clinton, which would be coded 0 for that comparison. Then we have a comparison between the other candidate. That group would be coded 1. Hillary Clinton coded 0, and then we have did not vote. That group would be coded 1, Hillary Clinton coded 0. So the first set of coefficients represents comparison again between Hillary Clinton voters and those voting for Donald Trump. And as we see within the model, only the economic liberalism variable was statistically significant, and you can see the coefficient is negative, basically indicating that persons who scored higher on the economic liberalism measure, basically scoring higher on liberalism, were less likely to vote for Donald Trump than they were for Hillary Clinton. But none of the other predictors in that portion of the model were statistically significant. We do see the odds ratio, which is given right here, is 0.208. And basically this indicates that for every 1 unit increase on the economic liberalism variable, the odds of a person voting for Trump change by a factor of 0.208. So in other words, that's further confirmation essentially that that as you're scoring higher on economic liberalism, you're less likely to vote for Donald Trump relative to Hillary Clinton. Okay, for the second set of coefficients, we have comparisons between the other candidate and Hillary Clinton, and again, only economic liberalism was a significant predictor in the model. So you can see there's our p-value that's given. Again, the coefficient is negative, indicating that individuals who expressed that they voted for an other candidate basically tended to score higher on or score lower on economic liberalism. And the odds ratio of 0.446 indicates that for every 1 unit increase on economic liberalism, the odds of a person voting for other candidate changed by a factor of 0.446. So in other words, again, the odds were decreasing with increasing values on the economic liberalism measure. The final set of coefficients represents comparisons between Hillary Clinton voters and those who did not vote. So we see that age was a significant negative predictor in this portion of the model, which indicates that persons who were older were more likely to vote for Hillary Clinton than to not vote at all. So the regression coefficients for economic and religious liberalism are consistent with the notion that individuals rating themselves as more economically or religiously liberal were more likely to vote for Clinton than to not vote at all. Nevertheless, these predictors were not significant in the model. Finally, we have our classification statistics that can be used to evaluate how well the model does in predicting group membership. And we see that Hillary Clinton voters were correctly predicted by the model at a rate of 75.8%. Donald Trump voters were correctly predicted by the model at a rate of 82.4%. Persons expressing that they did not vote were correctly predicted at a rate of about 55.9%. But the model does a particularly poor job of predicting those who voted for quote-unquote other candidate at a rate of 5.3%, which again is not a big surprise because it's just sort of a catch-all for all of these other individuals who happen to be in the presidential race. Okay, so that concludes our discussion. On the last page of the PowerPoint there are references that you can go to and read up on some of these topics, and in particular, if you want additional information on interpreting those logistic regression results, you can also click on these two links, and these will take you to PowerPoints on how to interpret binary logistic regression. So that concludes this demonstration, and I appreciate you watching.